Good, fine. Let's start putting a little bit of terminology on this. So how could I write a sequence? Like, how do I usually call a sequence? What notation do I use? Well, I usually give it a letter. And I put a little n down here. Okay, put a little n down here. What this literally means is my sequence is called u, and little n corresponds to the position of the term that I wish to calculate. So actually, I could come up with a rule. So it might be, for example, I mean, what would this be? What would this be? How would I describe this sequence here? So if I wanted to find any term in my sequence, could I come up with a rule to find that term? Sorry? Yeah, kind of. So you're saying that you're timesing by 3 each time, yeah? So you're starting with 1 and then you're timesing by 3. Now watch this. Would you be happy that I could define it in terms of the previous term? So I could say that to get any term in the sequence, I take the previous term. So what would the previous term be? So if un is, say, like the 5th term or the 6th term or the 9th term or the millionth term, how would I get the next term? -1? Yeah? Because if un is like a term in the sequence, I take the previous term, so n-1, and I times that by 3. Okay? That's one way of defining this sequence here. Okay, so this one here. Okay? That's one way of defining this sequence. But this is called something. This is something called a recurrence relation. Okay? It's called a recurrence relation because recurrence means it refers back to itself. Like, think of a recurring decimal, 0.63636363. I'd write that as 0. And then 2 dots above the 6 and the 3. Okay? The reason why is because it refers to itself. It refers to the fact that you take this 6-3 and you repeat it again and again and again. So recurrence just means it refers back to itself. Are you happy in this case? I am referring back to myself. I am saying to get the next term, I have to take a previous term. I'm referring back to itself in the sequence and then times that by 3. Okay? So this is something called a recurrence relation, when you define a term by using previous terms in the sequence. Okay? What if I didn't want to define it in terms of itself? So what if I didn't want to define it in terms of a recurrence relation? Could I do that? How? So how else could I write un? How else could I describe this sequence? So if I didn't want to use previous terms in the sequence, could I do it? Let's look at the pattern. In fact, let me write a few more terms out here. So I go 1, then 3, then 9, then 27, then 81. So yeah, good. I'm multiplying by 3 each time. So actually, let's number each of these terms. Would you be happy? This would be u1. Okay, this would be the first term. This would be u2. This would be u3, u4, etc.
3 and 10 square.
Okay. Yeah, kind of. So you're thinking about squaring going on, or you're thinking about raising something to the power of something. So let's think about this. So to get u1, you just start with 1. Okay, so you haven't multiplied by 3 at all. To get to u2, you've basically taken 1 and you've multiplied by 3 how many times?
3 times.
Once, haven't you? So u2, you multiply by 3 once. To get to u3, how many times have you multiplied by 3? Twice. Okay. To get to u4, how many times have you multiplied by 3?
3.
3 times. Okay, so you notice that you're always 1 behind whatever the number of terms you're up to. So u4, you've multiplied by 3 times. To get to u5, how many times have you multiplied by 3? Good. So you're always like lagging by 1. Okay. So what I've literally done here is I've started at 1, and then I've multiplied by 3 a number of times. So I've multiplied by 3, and the number of times that I've multiplied by 3 is 1 less than whatever term I'm up to. So if I'm going for u5, I've multiplied by 3 4 times. Yeah? If I'm going for u10, I've multiplied by 3 9 times. If I'm going for u11, I've multiplied by 3 10 times. If I'm going for u100, I've multiplied by 3 99 times. So it will always be 1 less than whatever term I'm up to. Okay? So you're happy this is another way of defining this exact same sequence up here. But the nice thing about this is it doesn't refer back to itself. It's not a recurrence relation. Okay? So that is an equally valid way of writing my sequence as well. So there's two ways. You can either write it as a recurrence relation, or you can write it like this. Now, what I have found here is a generalized formula. Okay, so it's a way of writing it's a way of finding any term I like in the sequence. And I find the term I like, say if I wanted the 100th term, I'd put n equals 100 in here. Okay, so I'm looking for the 100th term, which means I take the 99th term and times that by 3. Or if I want to use this formula, find the 100th term, I take 1, I multiply by 3, 99 times, 100 minus 1. Okay, so what I would call this is my nth term. Okay, my nth term. It literally says, find me any term you like in this sequence. Okay, so it's my nth term formula.